Hello there. In this video, we will be learning about the factors affecting friction. So we will be understanding how these three factors, that is, nature of surfaces in contact, normal force, and the surface area of contact will affect the friction. So let's try to understand this one by one. So let's say I have a box over here and the box is kept over a surface that is pretty rough that you can see over here as well, right? Now, let's try to push this box. So you are able to see as I'm pushing this box, the ground is applying a frictional force of 94 Newton in this case. Now what would happen if I make the surface smooth? Will the friction force increase or decrease? Now in this case, the surface is very smooth. Now let's see what effect does it has on the frictional force. Now you are able to see the frictional force is only 14 Newton in this case. So we can say that as the roughness of the surface increase, the frictional force also increases. So we can conclude that the rough surfaces create more friction because of more interlocking of surface irregularities. Let's try to understand what do we mean by the interlocking of surface irregularities. Let's say these are the two surfaces, surface number 1 and surface number 2, and let's say the surface number 1 is trying to move over surface number 2. So when it is trying to move, so there would be a relative motion between these two, and because of the relative motion, the force of friction will come into picture. Now the reason the force of friction comes into picture is because of the irregularities between these surfaces. Now if we see from a microscopic level, the surfaces are very irregular, and because of this irregularity, the friction is there. Now as the irregularity increases, that would happen in the case of a rough surface, the friction would ultimately increase. But in the smooth surface, the irregularities would not be that much, and hence the friction would not be that much as compared to that of the rough surfaces. Now let's understand the second factor, that is the normal force. Let's understand how the normal force would affect friction. But first of all, let's understand what do we mean by normal force. Let's imagine that there is a box of mass m lying on this particular surface. Now, there would be a force of gravity that would be pulling this box downwards, and that force is given by m into g. Now, the surface would be applying an equal and opposite force in this case. So, in this case, the force would be equal to mg, and this is what is called the normal reaction. So, the normal reaction is the force exerted by a surface. In this case, this is the surface that is applying this force, that is the normal reaction, and this force is normal, or we can say perpendicular to the object resting on it. So with respect to this surface, the force is at 90 degrees, and that is what is called the normal reaction. Now please note that the normal reaction is coming out to be mg in this particular case. It might not be for all the cases. Now since the weight of this body would be equal to mg, so in this case we can say that the normal reaction is equal to mg. So let's understand what effect does this normal reaction has on the friction. Now, let's say in this case, the mass of the box is 50 kilograms. So the weight would be 50 times the acceleration due to gravity. If we assume the acceleration due to gravity roughly as 10 meter per second square, so we can say that roughly the weight of this body would be 500 newtons. And if the weight is 500 newtons, in this particular case, the normal reaction will also be 500 newtons. Now, let's see what is the frictional force in this situation. So as I'm trying to move this body and the body has started to move, we can see that there is a frictional force of 94 Newton in this case. Now let's increase the mass of this body. So if we increase the mass of this body, now the mass becomes 50 plus 50, that is 100 kilograms. So we can say the weight would be 100 times the acceleration due to gravity, that would become 1000 newtons. So in this case, the normal reaction becomes 1000 newtons. Now let's see if it has any effect on the frictional force. Now as I'm trying to move this, you are able to see that the frictional force is 188 Newton, which is much greater than the previous frictional force. So we can say as the normal reaction increases, the frictional force also increases. Now finally, let's understand how the surface area of contact affects friction. Let's say I have this box and the mass of this box is 5 kilograms. So the weight of this box, considering g as 10 meter per second square, would be equal to, so we can say the weight in this case would be equal to 50 newtons And as we just saw in the earlier case, we can simply say that the normal reaction in this case would be 50 newtons. Now let's take two situations. In situation number one, the box is lying on the surface in this position, and in situation number two, the box is lying on the table, let's say in this particular position. First situation, when the box is lying on the table in this position, so we can say that the surface area of contact would be this much area, and in the second situation we can say that the surface area of contact would be this much area. Now in both these situations, the normal reaction would be 50 Newton, since the weight of both the boxes is the same, because these are the same boxes. But the difference is that the surface area of contact in this particular situation, in situation number second, is more as compared to the surface area of contact in situation number one. Do you think it will have any effect on friction? So we already know the reason of friction is the interlocking of the surface irregularities. So it will be only fair to assume that since in second situation or the second position, the surface area is more, so the interlocking would be more and hence the friction would be more. But is it really the case? Let's try to find out. So now let's try to understand how the surface area of contact affects friction with the help of this particular activity. Now here I have the same box but in two different positions, position number 1 and position number 2. Now as I am applying the force on this particular boxes, there would be some reading in the spring balance, and the reading would reflect the opposition forces. So the opposition forces in this case is the frictional force. Let's say I'm displacing both these boxes with the same amount, and I'm noting down what is the reading in the spring balance. So we will find out that the reading in the spring balance is same in both these situations. Let's say the reading in the weighing balance is 50 in this situation. It's also 50 in this situation. So the reading in the weighing balance is actually telling us about the frictional force, because the frictional force is the one that is opposing this motion. Now as the reading in the spring balance is same in both these situations, it tells us that the surface area of contact has no effect on the frictional force. But this is sort of contrary to what we were thinking initially, right? We were thinking that in the second position, since the surface area of contact is more, the irregularities would be more, and hence the interlocking would be more, and hence the friction force should be more. But as we just saw, that friction is independent of the surface area of contact. So how do we explain that? So the reason behind that is, when the surface area increases, the pressure on each point decreases, because we know that pressure is equal to force per unit area. So as the surface area increases, the pressure decreases, and as the surface area decreases, the pressure increases. So what actually happens that these two effects cancel each other out, so the net friction force remains the same. And that is the reason that in this situation, even if the surface area was more, but the pressure was less, and that is why the friction was not increasing that much. And similarly in this case, the surface area was less but the pressure was more. So both the effects are counteracting each other in such a way that the friction force is not getting changed with the surface area of contact. So we can conclude that in ideal conditions, the surface area does not affect friction. So I hope you are now clear with what are the factors affecting friction. So the nature of surface in contact: if the surfaces are rough, the friction force would be more. Normal force: if the weight of the object is more, if the normal reaction is more, then the frictional force would be more. And the friction is independent of the surface area of contact. See you in the next video. Till then, bye bye.